Welcome back everyone to this lecture on the check constraint. The check constraint allows us to create more customized constraints that adhere to a certain condition, such as making sure all inserted integer values fall below a certain threshold. So for example, let's imagine we're creating a table called example, and this is going to just have an example ID column, which is a serial primary key, and then we have an age column. And let's say for this particular example, we have to make sure that the people are over 21. So we'll say age, small integer for the data type, and then we add in this check constraint. And after the check constraint, we just have some condition, such as the age column must be greater than 21. And we can also set conditions based off other columns. So let's add in a new column called parent age, and then again, small integer as the data type. And for its check constraint, it's going to say that the parent age column must be greater than the age column. And so if you try to insert a person into this table who has an age that's less than 21, or if you try to insert a person here that has a parent age that is less than their own age, since that doesn't really make sense, we'll go ahead and produce an error. Let's explore this concept a little further in pgadmin. To show you what we can do with the check constraint, I'm going to create a new table, and we're going to create a table of employees. Let's say employees have an ID, and well, let's say employee ID, that's going to be serial, and it's going to be a primary key. Then they have a first name, which we'll say is a variable character. Let's give them up to 50 characters for their first name, and no constraints here. Or we can add something like, let's say not null. They need to have a first name. And then something else we can do is give them a last name, variable character, let's say 50. Let's say they also need a last name. And let's start adding things maybe like a birthday. So if we say birthday column, this should be a date. And let's make sure that the birth date happens to be greater than or past 1900. So we'll say check that the birthday is greater than, and we'll say 1900 January 1st. Basically, we won't allow anyone to say their birthday is before the year 1900. And now let's add in maybe last two columns. One column to say the date they join. So we'll say hire date. This is a date, and we want to make sure to check that their join date or hire date happens to be greater than their actual birth date. And let's change this to birth date, just so it's clear that we're not referring to just the day of their birth, but the actual date of their birth. Okay, so we have this birth date, and their birth date has to be greater than January 1st, 1900. And then we have their hire date, and their hire date has to come after the day they were born, which makes sense. And then finally, let's go ahead and give them a salary. This will be, let's say, a numeric data type. Just go ahead and have it be integer or numeric. So we'll say data type is integer. And then finally, let's go ahead and make sure that the salary has to be greater than 0. So we can't accidentally input a negative salary there. So we have these various columns along with these check constraints. You have a check constraint against a date, a check constraint against another column, and a check constraint against some salary or integer. We run this, we've created that table, looks good. Let's go ahead and now attempt to insert someone into this table. So we'll say insert into the employees table, and then we're going to go ahead and grab those columns. So those columns, we don't need to worry about the employee ID, that was a serial column. We'll say we're going to insert a first name, a last name, their birth date, their hire date, and then their salary. So those are the columns we're going to be inserting into. And now let's choose some values, basically just made up values. We'll go ahead and I'll choose some of my values here. We'll say Jose, Portilla, And then what I'm going to do is let's go ahead and add in some birth date. I'm actually going to insert some wrong values so we can see the check constraints at work. So let's say I was born on 1899, let's say 11/03, and let's say I was hired in 2010/01/01, and let's give me a salary of $100. So if I try to run this, I'm going to zoom out just a little bit so we can see kind of everything at once. We'll go ahead and run this. I get back error, new row for relation employee violates a check constraint on the employee's birth date check. Okay, cool. So it looks like that worked. Let's go ahead and change this. I'll make this 1990. We'll run this, and now I was able to successfully insert that. Let's go ahead and add in a new employee. Let's call them Sammy. Let's call this Sammy Smith. We'll go ahead and have them be the same birth date, but now let's accidentally say we put a -100 as their salary. We'll run this, and it looks like that fails the constraint for employee salary check. So remove that negative, run it again, and it looks like everything's working. So if we select all from employees, run that, I have both Jose and Sammy, same birth date and same salary. Okay, something that's really cool to notice here is that the serial actually kept a count of those failed attempts to insert. So I failed on my first attempt to insert, which means it started the primary key at 2. Then I failed another attempt, and then when I got Sammy right on the 4th time, it gave it a primary key of 4. So this actually lets you know that rows were either removed or insert commands failed before Jose and after Jose. So kind of an interesting aspect of the serial data type there. Okay, thanks, and I'll see you at the next lecture.